Good afternoon, ladies and gentlemen. Welcome to the IoT and Cybersecurity session of the Free Software Conference here at Neutech Park. Internet of Things was mentioned for the first time by Peter Lewis, 1985, and he defined it as integration of people, processes, and technologies with connectable devices and sensors to enable remote monitoring, status, manipulation, and evaluation of trends of such devices. Today, we count more than 50 billion of such devices connected in the internet, and this number is still rapidly growing or exploding. What are such devices? Such devices are smart home devices like fridges, TVs, radios, wearables, but also Internet of Things devices. And since these numbers are rapidly growing, there's a huge potential, but there are also risks going along with this risks of cyber security, which will be content of this session. But let me close now this short introduction part and start to introduce our first speaker. I would like to welcome Stefan Schmidt, Principal Solution Architect Open Source of Huawei Open Technology Center, and he will speak about the rise of IP6 IoT protocol. The floor is yours.
So, welcome everybody. So, after lunch break, so I guess everybody's a bit tired and so on, but better like that? Okay, sorry. Okay, so already introduced, my name is Stefan Schmidt. I'm working for Huawei Open Source Technology Center, and I will talk a little bit about the rise of the IPv6 protocol in IoT. So, I mean, for this one, it's like a 10 to 15 minutes talk, so it's really just a glimpse of what's going on. I will focus a little bit on the history, then I have like a main technical part, explaining a little bit about that, and then talking about more what kind of deployments we have and what kind of stuff we are working on, basically. I'm also focusing here on more on the embedded side, more on like microcontroller-based systems instead of Linux. I mean, on Linux, it's basically a given thing, so you can just make sure that everything is configured correctly. There's no need for new developments or anything like that. And I also focus on low power and low range wireless systems. So just to make sure that we have like a bit of focus here to make sure that we are on the same page. So for the history, if we look back, we see that there have been a lot of different network protocols and stacks throughout the IoT different systems over the years or decades, basically. So, but most of them have been, initially they only have been like homegrown, like one company wanted to bring out a new device or something, it has to be like some sort of connectivity with their own hardware, so they brought out their own standard or something. They never really had like thinking about interoperability and stuff like that. They didn't really care about that. They had their own vertical stack they supported, basically. And also in these times, TCP/IP was, I mean, some people thought about it, but they really thought it was way too wasteful to get that to these kind of really proprietary wireless stacks to get that in and waste kind of all kind of bytes on each frame, basically, to send out. So that was like where we started, basically. So then there have been work on getting a full TCP/IP stack working on microcontrollers, so something like micro IP or nano IP stacks. They have been focusing on making sure the whole stack fits into the RAM and memory requirements of such devices. So that has been work going on for a while, but there has been no real work on supporting like making the frames sending out over the wireless links actually smaller or something. So that support has been missing. So, and then there was always a problem that there's all kind of wireless technologies that have been used for that. But in, I think it was like 2003, the IEEE released a standard called 802.15.4. So that was like, at that point, that was the base where a lot of academics as well as companies looked into how they can use that in their product instead of doing something on their own. So 15.4, for example, is used in Zigbee. So that might be something you have at home with your IKEA thread-free systems or Philips Hue or something like that. That is all using Zigbee. So these are using this kind of wireless technology. So these chips are out there, they're available, they are pretty cheap and so on. So it makes sense to use them to build something else on top. And from this point on, the research communities and, for example, the ITF have been looking around and trying what can they do to adapt the IP protocols they have been developing over the decades before to adapt them to this kind of technology. And then from 2007 onwards, so they started to actually design and release RFCs based on that, how they can do that. This is basically known under the name like 6LoWPAN. That is something I will talk a bit more about in the details here. And it started with 15.4, but it has been adapted to all kind of other different connectivity technologies. So there's IP version, there's 6LoWPAN for Bluetooth, there's it for like power line communication, and all even like wired or wireless network protocols. So at that point, when the other people realize that these kind of technologies for header compression and so on, it's such a good thing to get like IP version 6 running there. So they realize they want to have their own adaptation layer to their own technologies, basically. And the key factors, but again, I will talk about that a bit more. The key factors here that we are basically taking the IP version 6 header and eliminating a lot of these things that are in there that are already available in lower layers, like the data link layer and stuff like that, and reusing that. So that's not really nice if you want to look at it like from an ISO model where you have like different layers and they are not interconnected at all. But from an optimization standpoint, it's really great. So in a nutshell, what 6LoWPAN is actually giving you is like one encapsulation, so it makes sure that all the things can actually get on the frames. So on the one hand, you have like IP version 6, and you have like a maximum transfer unit of like over 1,200 bytes. And on the other hand, you have something like 15.4, which has a maximum size of like 127 bytes. So that doesn't match well, right? I mean, and with IP version 6, they started to not have any fragmentation headers anymore because they don't want to have that for performance reasons, which makes a lot of sense in the normal internet. But for 6LoWPAN, we needed to bring it back because we need to find a way to do that. That doesn't mean we want to have packets that are that big, because from a performance perspective, that is really problematic, because if you have the more fragments you have that can get lost, then you have to retransmit the whole packet and everything. So performance-wise, that's an impact, and you really should consider that. But you still need to make sure that you can actually deliver this kind of big packets as well. So that is the encapsulation part. And then we come to the part where we actually talk about the technologies they started to use to make that feasible. And that is mostly header compression. So which basically means removing a lot of things in the header that is not needed because it's elsewhere, or it's like always set to the same values or something. I will have examples for that coming up. So in general, just reducing the size to make the frame smaller, to have more space for the payload and going on. And for this, there have been various iterations going on. So the initial RFC was like HC1 and 2 that have been like the first ideas they came up with, and after that they did a completely new RFC about IP header compression. That is like what is state of the art right now, and then they are developing on new things like general header compression and so on. But I mean, that all goes way too deep for like a 10-minute talk, but just to get you started. So what is this header size problem I'm talking about? If we look at one of the worst case calculations here, obviously to get the point. So as I said, the maximum frame size of 15.4 is 127 bytes. So the frame header itself of the protocol could be up to 25 bytes already. And then if you say you want to have encryption and all the other things already on the data link layer, not in something like TLS or something, but really on the data link layer itself, then you could enable LLSec, low-level security, and that could eat up again up to 21 byte. That doesn't mean it have to, it can be configured in different ways, but that's like the worst case situation. But even with that, then there comes a really big header of 40 bytes just for IP version 6, and another 8 bytes, for example, if you want to go with UDP. That means from these 127 bytes, only 33 are really left for your payload. That's not really such a big problem if you want only transfer like whatever 5 bytes or something of sensor data or something, that is okay. But if you want to like do more over that, it's just really wasteful to have that. So the ratio of like headers compared to like payload is really bad in that case. So what are we actually doing to change that? So the key part again is like reusing the addresses from layer 2, but there are other things we're also doing. So these examples are from the IP header compression standard. So things like there's a version field in the header. We know that we only support IP version 6, that is like given, that's defined for that. So we can set that to 0, so we don't have to transport that for every frame we are transmitting. The same is for like traffic class and flow label. That is something we are not using in these networks. Obviously, that means we are reducing the flexibility what the protocol is offering us, but for our use cases, it is not used, so we are setting it to 0, and we can delete it as well. Same for like the payload length. That is again SC addresses coming from other layers, so we have knowledge about that. We are breaking boundaries here, that is clear, but it's for efficiency reason at that point. But the biggest part, as I said before, is reusing the addresses we already have. So 15.4 has 64-bit extended addresses in the data link layer already, so that can be used as the address part of the IPv6 address. And then we can see the prefix part could either be known globally, that's something we can introduce into the network, like with a prefix that's part of the protocol you can specify, or it's already linked local, and then we know about it from the compression algorithm. So that means we can remove a lot of these things already. And with that, we can see that we can reduce really these 48 byte we had before for IP version 6 plus UDP. And we can really bring that down to, in an ideal case, obviously, again, to like 6 bytes. And in reality, in deployments, obviously, it's somewhere in the middle. So it's not being to like be only 6 bytes, depending on what kind of prefix we have, what kind of network layout you have, and so on. But that is something how it can look like. So that's really a big improvement. I mean, if you look at the payload part, you can see it's like 75 bytes. I mean, it sounds small, but that is for each frame you're transmitting. So that's really helping a lot. But there's some more miscellaneous tips as well. So as I mentioned before, fragmentation is possible, but you should really avoid it if possible, because it's really bad for performance. You're sending out the things, and even if just one frame gets missing, you have to retransmit the whole packet. That's just not efficient at all. And then there are things like for 15.4, for example, they offer things like a reliable data link layer already, so you can retransmit the frames instead of the packets on top of that. You can enable that. That is also helping a lot. And then next thing you would optimize is like, don't go the full path with a full three-way TCP handshake, for example, if you can avoid it. You can, if you want to have like something like TLS, you can go with something like DTLS for UDP and TLS together. As again, always like pushing things here. So then the ITF is also designing other things in that regard, like routing protocols based for this kind of lossy networks. That would be RPL, for example. And then there's like application layer protocols on top of that, like co-op. Just examples here. So in terms of deployments, we see a lot more of that going on. If you look at, for example, the Zigbee group, they actually renamed itself to like CSA, I think, Connectivity Standards Association. I'm not sure about the rename here, but they switched to bring out a new standard called Matter. This is actually based on IP version 6. So they are also reformatting that way how they approach that. And we also see deployments on the data center side already, where companies like Google and Facebook having IP version 6 only data centers because they can control all the environments there and have only the translation at the edge of the network. And that is something you can also see for the IoT part, for like smart meterings and stuff like that. You see these kind of 6LoWPAN deployments already. I mean, we are not seeing them, but they're already there because it's an isolated network they can control and then can deploy it easily. But for our homes and stuff like that, it's just more complicated. If you have like something like a thread network or something like that, that is also running on IP version 6, that is also an isolated subnetwork that could work, but integrating it all into your home network, that is really complicated. And that is actually something I've been working on the Oneo project for a while now. So I'm looking into a transparent gateway group hint to get all these things working. So we are working on getting an open thread radio working and then have a mesh network based on that, running IP version 6. And later on, we want to bring things like Meta and stuff like that on top of that. And I really need to speed up here. So basically, as you can see, we have it like here for OpenThread. You can things run like MQTT or CoAP or something. And it would also work together with Wi-Fi. So like the IP version 6 package just flowing through. You have like an end-to-end communication from, even if you want, from your data center up to or your cloud up into your device or something like that. But you can also run it over something like Bluetooth Low Energy if you want. And with that, I'm done. And I have 7 seconds for questions.
Yes, very short question. Okay, so
I'm around.
There is the Onero booth outside. Yeah. You can go there and get in contact with the Huawei.
Yeah, we have a video demo above there about the gateway. I'm around, and if someone is interested, we have a dev day tomorrow for like 4 hours, which is not only about that part, but we are running the gateway as a demo to get that running on something like that. So there's still a few seats left or something. Okay.
So thank you to Stefan Schmidt.
Okay, thank you.
So we are entering now a small break, and see you again in 5 minutes. Welcome back to our IoT and cybersecurity session of SFSConf. I would like to introduce you our next speaker, who is Roberto Innocenti, President of the Power Progress community, and he will speak about the PPC64 Open Hardware Notebook project. To you, the word, Roberto.
Hi. Okay, thank you to attend even this year. I'm very happy about that. Sorry to not be present in person. Next year I will be. I want to only make a short summary. Our association, because this project is starting from an association, a profit association, that was founded in 2016. The donation campaign that permit us to start the design of this open hardware notebook started the year 2017. And then a good number of volunteers joined the association in this 2016, 17, and so on. And in the 2018, was realized the donation campaign to make the electrical schematics. Between 2019 and 2020 was the time of donation campaign to realize the PCB. And in this year was the time of donation campaign to produce the 3 prototype. No? So every year we have reached, thanks to the donor, each step related to each goal, that was electrical schematic, PCB design, simulation test bus, and production of prototype. I want only to introduce a little bit our mission, that is not only related to open hardware design, but is related even to reuse dismissal of cost hardware, and even to, in any case, encourage people to use open source software, and even to promote innovation and library scientific programs that are in respect to variety and multiplicity, to reduce the monopolies. So, as we are an association, we have set up because we are hobbyists, so we use our spare time or our free time to collaborate. We have not a rigid business plans because we make something volunteer and we depend from the donation. We have selected, when we have started, to design an open hardware notebook based on power architecture CPU. This was for different reasons, for efficiency, for the very open design of the architecture, that is an open eyes like RISC-V. And recently, even Open Power Foundation, that is the association, the foundation which our association is a member of, have with RISC-V have even organized a new Open Hardware Diversity Alliance, so it's something that we think is a good move. PowerISA, so Power Architecture use for a newer CPU an OpenISA instruction set. It means it is not closed, and have a long history starting then more than 30 years ago. So it's something that is very, very mature. And there are not only CPU for APC, so server and so on, like IBM Power 9, 10, 8, but there are even low power cores, like from Microwatt and LibreSoc, are in this moment are near to the fabrication, so it's something new in the last 2 years. But in any case, there is an open future about that. So we'll see new power architecture CPU even with lower power. From our point of view, open source hardware projects are very welcome if arrive from anyone. For our point of view as association is matter even who is driving the open source hardware projects. Company that drive open source hardware projects have profit, or in some case as Extractor, as a main interest, and even have the interest in open hardware and sure to pay the salary of its employer. Community-driven projects are little different because the community is the protagonist, the people volunteer are the protagonist. The goal are the Extractor, so it's something that is not constrained to the profit. So thanks to the aspiration, in our case, the aspiration is open hardware project around GNU Linux, but other association can have a different activity. So any step needed, so design, paid engineer, make the prototype, find a company that produce the notebook, are oriented from the community. That is quite different from company. In any case, as we need to need the help of company engineer, and so people that are paid to design for our goal, as we have not the capabilities or the time to realize a complex project like our, is very important, is in charge of us to sensibilize, to sharing the culture between companies that collaborate with us related to open source hardware. We have selected, was possible to select a different architecture thanks to open source software. No? Thanks, in this case, particular case, to GNU Linux distributions. We have made a donation campaign because we are a non-profit association and because we still have not a prototype. We'll have soon, after the electronic shortage will be less strong. So now we are in hardware tests campaign. We will make a certification about open source hardware when we have tested the prototype. I have already told you this. So in this moment, we have ordered the more than 2,000 components for our notebook motherboard, and we still have not all in our hand for the shortage situation. We have printed a PCP dummy to check that our design fit.
So we have a connection problem. We try to fix. I ask you for a little patience. Yeah, but it seems that the connection has gone. So we try to re-establish it. There are 5 minutes left. In the meantime, I can ask you to write some questions in the elements chat, or prepare some questions we can ask Roberto. Okay, so I get some negative signs from our technicians. I fear that we lost Roberto Innocenti. So it is a real pity, because we have seen how he did a great job in growing his community and realizing some nice hardware projects. So that means that we enter the break earlier, and see you in about 10 minutes for the next speaker, which is Manuel Virgilio, who is also in the same Power Progress community. Thank you for your patience. Welcome back to IoT and Cybersecurity session of Free Software Conference. Let's introduce our next speaker. We welcome Manuel Virgilio, tech enthusiast and FPGA specialist from the Power Progress community, and he will speak about NXP T1040 based single board computer. Manuel, to you the stage.
Hello, and thank you to everyone. My name is Manuel, and I am a member of the Power Progress community. As Roberto tried to tell before, we are a non-profit association, and we work around different points in special. In this session, I try to tell you what I'm doing around the CPU, the NXP T1040, because one of the activities of the association design some kind of open hardware, and in fact we have a notebook that is a project that starts a long time ago, and that is coming to be reality just in these days. And in December 2020, I had the idea to take all the material that was developed for the notebook and try to build something more smaller, more cheaper, because the notebook will have a kind of price, and I was thinking about to build something that could be usable by school or by students or by enthusiasts or some hobby, just to try another architecture, because a lot of devices around.
Mr. Virgilio, if you hear me, please switch off your video camera, just leaving the slide and the audio on, so it's easier to follow. Thank you.
This is better?
Yes.
Okay. This project is about building something more smaller than a notebook, more cheap. We choose PowerPC. I choose PowerPC because I want to use all the material developed for the notebook. And some more point in advantage for PowerPC architecture is that this architecture is used in a lot of segments like avionic or space or the computing. And it could be used in some for educational material, because in fact I developed a lot around the model-based design just for this kind of architecture, and I think that could be really educational and simply to use. Model-based is just just an approach, but works very well with this kind of CPU. And I think that at the last point, there are good news about the PowerPC architecture, because there are a lot of projects that are developing around the PowerISA instruction set, and one of these is LibreSoc. That is a project that aims to develop an ASIC, and the PowerPI, that is a group of the Open Power that I think that should start in a month or something like that, and they will develop a board like the Raspberry, so it's like the Django. But the topic is that Django will be open to not only for PowerPC, but the reason is that it could be adapted to any kind of architecture. For Django, I choose the CPU T1040, and this is the last CPU available, the last generation available from NXP. It is a low power CPU that is used in embedded devices. So we don't have fast interfaces, but we have a lot of connectivity. I want to show you here that we have DDR4, we have a gigabit Ethernet, because this is a network CPU, so the connectivity, the Ethernet connectivity is something that the CPU do very well. We have two USB 2.0, and I place a chip for having 4 USB 3.0. Then we have SerDes connectivity on the CPU, and I just place two kind of connectivity that use PCI Express. This M.2 KM and M.2 KB. The good of having the M2 KM is that we can use also some video board. There are some video board that that have the interface M.2, and there is the possibility to use a flat cable that exports the standard PCI Express slots. Then the CPU itself has 4 core and the 64-bit, 64-bit, and has a good amount of cache and is a recent, is the 2040. So I develop the schematics that you can find here in the GitLab repository, and I show you some sheet just to show that the schematic is almost ready, but I need some review, some time to finish some porting around the one big component, because I realize a lot of work around the notebook and the demo board, but these two boards use the FPGA. That is a big component. Around the FPGA, there are a lot of components. For this board, I don't need so much resources, so I cut out the FPGA and I place a PIC, a microchip PIC, a microcontroller. And around this component, I need some help to finalize the schematics. So this is a scheme block that shows the structure of the board. On the right, we have the internal connectivity, the DDR4, the flash, HDMI, that is for having video connectivity, but the CPU doesn't have a video card or a GPU, so this is a simple frame buffer. We have SD card, the connectivity for JT, and on the left we have the two USB 2.0, 2 gigabit Ethernet, the PCI Express connectivity on the M.2, the USB 4, one serial connector, an either DIP that is it should be something for hobbyistic purpose, and the RS-232 that is a standard serial for the pack. I want to show you something like the power rails, that we have all the power rails and the switch that turn on or off the power rail, and the sleep rail that is for hibernation of the board. The connectivity for DDR4 that is complete. We have the connectivity for USB 2.0. So we have on the top the pin on the CPU, on the bottom the connector and the filtering, and on the top right the section of power. the Ethernet connector. This is 2 Ethernet connectors on all the filtering section. The part of a video. So on the top left, we have the pins for the CPU, the serializer on the center, and all the possibility to set addresses for the interface that control this chip. And the next page, the chip that used to encapsulate the DVI on the HDMI. Next, we have the power input, the main power input that produce the 5 volt for all the internal rails. The EFC interface that is used to communicate with flash. The power stage for the 1 volt, the V-core. It is the stage that absorb the majority of the current. This is all power stages for minor tension, so 1.8, 2.5, and 3.3. The chip for the Ethernet, we have 2 Ethernet, so we have 2 chips, and I use the microchip chipset. This is the stage for the SerDes on the bottom. If you see, we have a lot of line that goes to the endpoint 2, the RX-TX, and to USB 3 on the left, and at least the serial data. And on the top, we have the connectivity for the Ethernet. So this is a good schematic, I think, and we have the section for the clock, section for the SD card, and power supply, ground, the flash, and this is the sheet that I need to complete. It is about the peak, that it should control all the power initialization at boot time and at hibernation time. And what are we looking for? We are looking for people that could help to finish the part of the schematic and start the part of PCB. So the main topic of the Django is to try to bring people together that likes this kind of activity and wants to develop at this moment the Django, but in the future something else. And I think that is a cool activity because you have the opportunity to talk about something that you usually don't speak to. I mean, sometimes I speak to someone of IBM or someone on NXP. So I think that it is a good opportunity to meet people and to doing something that not so many people today are able to do. Do you hear me?
Thank you, Manuel, for sharing with us your experience in your open hardware project. Are there any questions from the audience? Not for the moment. Manuel, we wish you all the best, and so you are here part of a community with a lot of other tech enthusiasts. I'm sure you will get contacted by one or the other which would like to be part of this nice project to build a computer.
Thank you. Thank you a lot.
So, and we will see you in 5 minutes, and we'll take our time to connect with the next speaker. Thank you. Hello again. Welcome back to the IoT and Cybersecurity session of SFSConf. Our next speaker is here, is Stefano Tondini, Senior Researcher of URAC Research in the Center for Sensing Solutions. And he will speak about an automated calibration for low-cost air quality sensor. The floor is yours.
Thank you very much. So, good afternoon, everybody, and I'm really happy and pleased to be here at the Free Software Conference. And today I'm going to speak indeed about the preliminary results of the first project, which acronym means Artificial Intelligence for Wireless Sensor Networks. I'm speaking on behalf of my co-authors, that they come from different institutions, and I will thank them again at the end of the presentation. So actually, we are talking and tackling with a problem when it comes to low-cost sensors. That, of course, they are cheap. But then, to provide us with some meaningful information, they need to go through often and expensive calibration procedures to give us some reasonable data. And so what we want to achieve and to accomplish is an automatic routine to get rid of this, or not maybe get rid completely, but at least having something a little bit more scalable when it comes to the pervasive distribution of these low-cost sensors in urban context, for instance. Okay? I'm going to focus my presentation on air quality sensors, but these can be also extend and expand. Let me thank the partners and the support that we had for this project from, of course, the funding scheme, the Sparkasse of Bolzano through the Fusion Grant, the Orma Solution Company, and then the Digital Transfer Unit of the Noi Tech Park, joined with Fondazione Bruno Kessler with the Micro Nano facility, the local environmental agency, and last but not least, University of Bolzano. Here is the condition we are actually working in. This is the monitoring station located in Piazza Adriano here in Bolzano, where we are hosted with some low-cost sensors. But anyhow, let me precise in the beginning that we are having some tubes that you see on the roof of this container that bring an airflow, a controlled airflow inside, where some high-resolution measurement instruments are located and working constantly. These are managed by the local environmental agency. And actually, here we can see the detail of what is a tube, the head of the tube that brings the air inside. And here is inside the cabinet, where we do see these two tubes, one close to each other. And the first pipe gives, indeed, the samples to the high-resolution monitoring systems that are there hosted. And the second one, you can see, is hosting our own low-cost sensors. They are basic and commercial low-cost sensors, even though you can see in the bottom part, we are also onboarding some prototype sensors from Fondazione Bruno Kessler. And the last detail that I want to give you about our sensor configuration is this last image, where we see on the roof of the container, we are also having another cabinet, a black box, that is hosting another sensor, low-cost sensors, like the one we are having inside. And so let's go to the reason why we put such a configuration in place. Here again, the same as before, it's just a schematic. We do have the high-resolution equipment inside the container, okay, with this tube with air inlet and air outlet. And then we placed 3, 4, 5 low-cost sensors, one inside the cabinet, one on the roof, and then we can distribute also around the city. Now our question is how to put in place a way, a method to calibrate these sensors without the need to move them physically, each of them, inside the cabinet, because this is what actually is making so much effort to be done, needing so much effort to give the sensors a good readout, okay? So, first of all, we need to make them speak toward each other. Pretty easy. But then, we should take another hypothesis, that these sensors are similar to each other, okay? And when this hypothesis holds, let's now see what we put in place. We have the raw data going into a machine learning engine, okay, that is having as input also the reference curve from the high resolution measuring station, and also the microclimatic parameters that are inside the cabinet. They are pretty controlled and stable. By doing that, we can end up with the low-cost sensors, the orange one, calibrated, of course. That is pretty trivial. Everybody does like that. And of course, we are having the confirmation that this works by looking at the correlation between the reference curve and the orange sensor. But then our point is, now that we are having this engine that is trained for one sensor, and if the sensors are similar to each other, we can directly use this engine, no more train it, just use it to predict what is going to be happening to the other sensors along the city by inputting the new microclimatic condition that they are experiencing. For instance, between inside of the cabinet and outside, we do have different temperature and humidity. Of course, inside is pretty stable. Outside is varying on a much, much greater scale, okay? So we input into the machine learning engine the second curve from the second sensor, the blue one, okay? We use the same weights, the same features of the previous calibration. We just input the new microclimatic condition, and if this approach holds, we will figure it out whether we do see some correlation between the new reference, that is going to be our orange sensor, and the blue one. I'm spending a couple of words just about the data workflow. Of course, we are hosted by the Free Software Conference, so let's point out that we do everything by means of open source compliant components. We do have the two data sources, the Open Data Hub of South Tyrol and the InfluxDB instance that is actually having inside the data that come from our low-cost sensors, okay? Then we use some Grafana dashboards just to have a rough and fast visualization of the time series to see whether they are still going on or not. Then we use Jupyter Lab, a notebook that is shared among URAC and the University of Bolzano, this node, in order to process the data and to build up the machine learning engines. And of course, we share all the code by means of GitLab. Now, let's go into the data a bit. In the plot, you see the gray curve, that is the reference one, coming from the high resolution monitoring station. Just a detail for you. This curve basically costs 3, 4, 5, 10,000 euros, okay? Then we have our own sensor inside, the orange one, that comes for 50 euros, basically. So you can understand how much is the difference. And anyhow, we can see a bit of same trend. Of course, we do have an offset, and that is a bit of an issue because, I mean, we should not only see the trends, but we should also be compliant with the order of magnitudes, okay? Anyhow, after a certain period, 3, 4 weeks, 1 month, we added a new line, the blue one, okay? This blue one is the sensor put on the roof that is having a further different behavior with respect to the reference one. Looking at the correlation between the orange and the blue curve in the period that they are, of course, both present, we do see that there is basically nothing looking at the Pearson coefficient, okay? But then, again, let's start with our routine. We train the model, the machine learning engine, in the previous period where we have the reference and the orange sensor going on, okay? We do have the machine learning engine trained, and here you see that we can basically, with a really good agreement by looking at the correlation, okay, we can basically shift the orange curve on the black one. Again, this is pretty common and neither more state of the art. But now, let's try to see whether we can take into account the orange curve to be the new reference. Don't train the model, but just use the model that's been already trained for the preliminary data set, the 1 month where we have the gray and the orange one only. And let's see what happens on the blue data when we input them with, be careful, the different microclimatic parameters, because we are no more inputting T1 and T2, the two temperature and humidity that are inside the cabinet, but we are now taking a look at what is outside. And what we see is that with a certain degree of accuracy, we can again shift, by means of only prediction and not training, the blue curve to be in a certain overlap with the orange one. Of course, it's not perfect, but this is just an example we took for one specific parameter without taking into consideration any kind of cross-sensitivity. That could be a big issue, because if we are now inputting no more temperature and humidity, but also some other gases that are interfering on the readout of the sensor, this could be improving much, much more, okay? We could end up with some regression that is much more aligned on the diagonal, okay? And again, let's also take into consideration that we are using only 1 month of data for the training and 1 week afterwards for the validation of this approach. If we will be having a much, much more longer time series that we hope to have in a few months, we will be able also to map a bit the change of the microclimatic parameters that the sensors will go under all along the year. And this will help us a lot to improve this kind of method. Anyhow, let me conclude to say that we have been able to, again, by means of no more training and no more rigidly bringing the blue sensor or all the other sensors distributed around the city close, physically close to the reference to be calibrated, we had a bit of these preliminary results. I'm now concluding and looking out at some possible follow-ups. Of course, we will be trying and benchmark a lot of different methods to see which one is much more suitable for that. Maybe also the hybridization of them is going to be something that we will try it out, because this is pretty trendy now. And of course, we want to scale up and to make it autonomous for much broader wireless sensor networks. And what we are actually looking at is to put in place something that helps us to do aging prediction and maybe drift compensation when the references and the low-cost sensors time series will be too much far apart from each other, so no more valuable information. This is what we foresee to be is going to be really suitable also for mobile microclimatic monitoring, where the fact that we are no more into an inertial framework is going to take a big role in this. And of course, why not to try to look at some other kind of sensors, no more higher quality, but many different parameters that can be interesting. And with this, I thank you all for your attention and my collaborators for the job done.
Thank you for your interesting talk. Are there any questions about the calibration of sensor? Please, could you come here to the microphone so that our online participants can hear your question?
Okay, thank you, and thanks to Stefano for the presentation. I've got a question. You talked about cross interference between gases, and my question is the following. You can have two approaches in solving these issues of interfering gases. The one is to do a fully data-driven, a fully data-driven approach in machine learning. The second one would be to rely on information given by the producer. And I would like to ask you if in this approach, which one of the application is the better one from your point of view?
No, thanks a lot, Gianluca, because this is indeed a really interesting point to discuss. Of course, doing it by machine learning helps you to get rid of too much thinking about what physically is happening. But, of course, the producer sometimes gives you some analytic prediction of what should be the different interference. The point of us right now is not to consider what the producer is giving, because, for instance, sometimes you get some analytical formulas that help you to correct a bit your data. But this one usually are dependent on some really few bench of parameters, for instance, only on the temperature. While we are really looking at mapping the microclimatic parameter at all that is in the surrounding of the low-cost sensors. Why to do that? Because...
sorry to interrupt you, we heard the gong, so I ask you to maybe continue the conversation afterwards, and so thank you again for your
very much.
Contribution.
Thank you.
So, thank you. Welcome back to our IoT and cybersecurity session at the SFS Conf. Let's welcome our next speaker, Mrs. Sadaf Mohaveine Jat. who will speak about climbing route clustering using energy-efficient sensors. To you, the stage.
Everybody, my name is Sadaf Mobenneja, and now I want to give a summary of my work about climbing route clustering using energy efficient sensors. And this is an activity which is important for climbing gyms, and in the following I will explain for you how we are going to do this. Oh, okay. And this one? Why it doesn't go? Okay, first I need to explain for you some general terms in the climbing activity, which is what is line and what is route. In climbing gyms, there are different walls, and each wall, which you see in the figure, has different lines, and each line has different routes. And the routes share the same quick draw, and the routes have different difficulties. And quick draw is a piece of equipment which is used to to attach the rope to the anchor which is connected to the wall. And the problem which we want to solve is related to route detection. This helps the climbing gym to know which routes are climbed more, and this way they can improve their services for their climbers. And to solve this problem, we have different challenges. The first challenge is related to the climbers, because the climbers, we must consider their privacy, so we cannot use camera, and we need to use sensor instead. And these sensors cannot be connected to their body because they don't want to have something on their body when they are climbing. And we connect these sensors to quick draws, and we call it smart quick draws. The second challenge is related to the climbing gym, because they don't want to change the batteries regularly, and we need the sensors to be energy efficient. And the third problem is for data collection. We cannot collect many data from different routes and then use it to train the model, because this way we cannot use the supervised models, which needs prior data. That's why we use unsupervised algorithm, which is called clustering. And this is our data acquisition system, which consists of three main parts. The first is the smart quick draw. A smart quick draw is a sensor plus a microchip. The sensor measures 3-axis acceleration, and the microchip has a microcontroller unit which controls the sensor and put it in active mode and sleep mode, and also change its sampling rate. And there is RF transceiver, which helps the sensor to communicate with the Raspberry Pi. And the Raspberry Pi plus another microchip is our base station. This receives data from the sensor and send them to the database. And all the data is stored in the database. And we connect to the database to analyze our data, and then to develop an algorithm and use this data. And we did experiments with two different climbers. One of them was a young man who was 27 years old, and he had 10 years of climbing experience. And the second one was 65 years old with 30 years of climbing. They climbed route 5C+, 6A+, and 6B+, which according to the standard are difficult routes. And we collect data in 3 different days, and with these two climbers over these 3 routes. And we changed the order of the climbing because we want to add other parameters like tiredness and provisioning. Then it would be more close to the real case when there are different climbers with different skills in climbing gym. And from all the sensors, we extract feature vector. So from each sensor, from the time it's clipped till the next one being clipped, we extract a subvector and put all these subvectors together to make a main vector of the line. So this vector of features has two main types of the features. The first type is statistical features along x, y, and z axis. And the second one is the temporal features, which correspond to the time that the climber spent between two quick draws or between each quick draw and the beginning of the climb. But these features are too much, and we need to optimize them. The first step of optimizing is to scale them, because in order to not to allow one feature which has a higher value to dominate and affect our algorithm more, not because it's more important, just because its value is higher. And to do this, we use a scaler which is called quantile transform. And the second step is the selection. This helps us in two different ways. First is to improve our algorithm to be more efficient. And the second one is to know which sensor doesn't provide us useful information, and we can delete that sensor, and it simplify our hardware. And we give all these features to a clustering model, which is Commons, and to see how this model is performing. First, we sort all the features based on the scores, and then we give them a subset of the features to our model to see its performance. But since this model in Commons is a bit random, it has a random behavior, I run it over 100 iterations to be sure that which number of the features is 100 iterations is better than the other. On the left side, you see the case when there is one climber without any prior practice. And this means that if we can identify the climber, we can have a perfect clustering with 3 features. Over 100 iterations, we always had a RAND index equal to 1. RAND index is a metric to show how well the cluster model is performing. And on the right side, you see when we mix the data from 2 different climbers, and for the case that we cannot identify the climber and we have a mix of data from different climbers, and here we need 16 features. In that case, the minimum performance is equal to maximum performance, and it's 96. RAND index here is 96 with 16 features. And here to visualize the result, on the bottom you see the grand truth, and on the top you see the predictor labels. And here is just one mistake in 33 climbs of 2 different climbers, and here is the information which I gave you before about how this data is collected and the detail of the algorithm I'm using, which scalar, which score function, and which features, and the clustering model. And this is another way of visualization. So I convert that 60 features to 2-dimensional feature space using principal component analysis, because I want to show it to you, and you can visually see how they are clustering. And on the top left, you see the grand truth. And on the right top, it's how Gaussian mixture model is clustering these points. And below that, you see how Commons model is clustering that. And on the left bottom, you see the Silhouette coefficient values for the Commons, which shows how well the points are clustered internally and externally. And as a conclusion is that when we have a single climber, only with few features we can have a perfect clustering. And it's also true when we can identify the climber. But if we cannot identify the climber and we have data from more than one climber, and in this case we need more features for good clustering. And these features are mainly related to the quick draw, which are in the second half of the line. And this is the part which, when we were in climbing gym, we visually saw that it's the part that the routes have different difficulties. As a future work, we are working on orientation as a new feature for detecting different activities in climbing gym, orientation of the smart quick draw. And thank you, and if you have some questions.
Thank you, Mrs. Moavinijad. Questions? So if there are no questions, then I have one question. So I asked if you can be sure that your model is independent from the anatomy of the climbers. So
Yeah.
if you have a big, small, tall, and climbers.
Yep. I think yes, because these two climbers, one of them, the young one, was tall, and the old guy was shorter, much shorter. And also, these sensors are not attached to the body of the climber, and it's attached to the quick draw on the wall. So it's independent of the climber. It's just related to the performance of the climber during the climbing, and it's just related to movement of the quick draw.
Ah, okay, they're fixed in the withdraw.
Yes,
the
they are on
the sensor.
yes, not on the body of the climber.
And are there solutions also which use the sensors on the climber itself, like
Yes,
smartphone accelerometers or GPS data, other data?
Yes, there were before some works who put the sensor on the hand of the climber or on the hip of the climbers, but climbers in real world, they don't want, when they go to the climbing gym, they don't want something artificial on their body. They want to be more natural, and that's why we face this challenge.
Okay, very interesting. Other questions from the audience? Otherwise, so with your experience in this research project, what would you recommend to someone who is interested, who would like to start a project to use to use sensors for measuring sports activities and to model the sports performance? Which would be your recommendations? What should be absolutely considered?
Now it's popular, especially in some sports like football or yes, also in maybe people have their smart watches and then application in their phone which track their activities during running, during cycling, and then also for football matches. But it's just they started for the climbing. It just started. But to have some specific recommendation, maybe the topic which my colleague is now she's presenting is about the recommending the routes for the climber. That could be maybe more interesting to recommend based on the experience of the climber and their previous routes they climb, to recommend them what to do to improve their skills and improve their performance. This is the recommendation for the system.
And how important are the right enthusiasts and sportive people to get involved? So they should be so high performer, or there should be a quite broad variety to have training data which is suited best for.
Yes, we need more data from climbers because except this task, there are other tasks we are doing about detecting different activity during climbing. So when the climber falls, when the climber is going to have a dangerous situation in the near future based on the activity he or she did. So we need more data from the climber to analyze different activity of the climbers.
Okay, so if there are some climbers which are interested to contribute to such a project, then they are welcome.
Yes.
So thank you again for your contribution. And see you back in 5 minutes for the next talk. Good afternoon again. Welcome back to the IoT and Cybersecurity session of SFSConf. Our next speaker is ready. It is Lucas Lasota, Vice Coordinator of the legal team of the Free Software Foundation Europe. And he will tell us in his presentation how to protect router freedom within the EU reform of the telecom law. You the word.
Thank you very much. Hello, everybody, and thank you for the introduction. I'm very glad and very honored to be here again. This is my third time in the FSCon, and it's a pleasure to talk about this very important topic because it concerns our freedom. It concerns our ability to choose and to use our own internet equipment. So today I would like to talk with you about router freedom and why there are some issues within the reform of telecom law. So this talk will take from the principle the policy and legal developments. Until now we have been pleasure hearing a lot of technical details in the previous talks, but now it will be focused more on policy and legal developments, and I would like to bear in mind, and this concerns all of us in Italy, here where we are, and also in Europe. Well, my contacts are on the screen, so after this talk, if you have some questions, if you want some feedback or some follow-up, please feel free to reach me. Okay, so today we will talk about what is router freedom and what is the concept of technological necessities and why this is a problem for our ability to use our own routers and modems in Europe. I will give overview about what is going on with router freedom in Europe, and perhaps most importantly, how you can contribute, how you can help us guaranteeing your ability to use your home router in your home, because this is what is in danger today. So just to contextualize what is happening in the European level, I would like to propose food for thought here. Imagine that you are moving to a new home, okay? So besides of having all these kind of problems in finding a proper moving company, you need to get all your contracts done. There's a lot of things going on, and you have to, of course, well, get energy running, you have to need water running, your telephone running, your internet running in your home. But then suddenly you received an email or you received some information from the electricity provider saying that your freezer, your microwave, your toaster, or any other device in your home, it's not compatible with the electrical line. And now you're puzzled because, well, in my previous apartment in the same city, everything was working. And why I cannot use my own freezer or toaster or microwave? It complies with the standards of the European, well, framework. What is that? But the electricity provider said, no, I'm sorry, our plugs, it's not compatible with your equipment, so you cannot use it. Moving forward, the same provider does not allow you to use your TV set, your smart lamps, or Bluetooth gadgets, smart home devices. And now you are in this position to say, well, why is that? All these devices were working perfectly in my previous home, and in the same city, I just have another provider, and now I'm stuck in this position. So you cannot understand like this. Well, perhaps maybe some of you think this situation is a little bit far-fetched. Well, I would like to say that no, it's not far-fetched at all, because right now in Europe, with the reform of telecommunications law, internet service providers, well, in some cases, they can prohibit consumers to use their routers based on technological necessities. Well, and just to give a practical example, my colleague Max here and me, we have some issues in Germany when our providers, they were like not allowing us to use our own routers. But coming a little bit back, what's the difference of this kind of device, the router device that we use to connect to the internet, to the other type of device that we use in our home? Well, it's our liberty, it's our freedom to choose the device to use that we wanted to have in our home. Well, but let's then recapitulate how we reached this situation, this very bad situation that we have right now. Right, let's start for the beginning. In 2015, we had a piece of legislation in the EU, very nice piece of legislation called the Open Internet or Net Neutrality Regulation. And there, this is a European law saying that users have the right to use a modem or router of their choice, okay? However, then we had a huge debate in Europe saying, okay, this is not a policy or a legal issue, this is also a technical issue, and therefore we need some technical documentation, technical implementation of some guidelines that will very precisely codify when the network, the private network of end users will begin and when the network of internet service provider will begin. So in 2020, we have the BEREC guidelines on the NTP. NTP means network termination point. So it's this point where the two networks, the private and the public, begin and finish. So, and now the problems begin. Because in these guidelines, it's written that ISPs can impose their own routers on end users based on technological necessities. And yeah, and here things start to not going very nice for end users. And we will see what does that mean right now. Right, so according to these guidelines, and BEREC, just you to know, is the European regulator, so network regulator, so all the activities involve internet, international connection, they have the utmost authority to regulate these things on Europe. So they listed a bunch of technological necessities. They're saying, if an internet service provider says that due to interoperability between the public network and the router, or perhaps simplicity of operation, or perhaps network security and data protection, ISPs can say, look, to end users and to consumers, they say, I'm sorry, you are not allowed to use your own router, you have to use mine. But for me, this sounds quite strange, and I don't know for you, because remember then from the previous slides, my router serves me very well. I installed my router, and my router complies with standards. My router complies with security standards. And now just because one internet service provider thinks that my route can be problematic, I'm not allowed to use a router. And perhaps you know that router is a very piece of equipment. It's a gatekeeper of all our internet connection. So all the data that pass, our personal data, work data that we use, pass through a router. So in order, and this track is all about the security, so it's important for us to know what is running inside our router. And that's why we at the Free Software Foundation Europe, we believe in router freedom. So router freedom, it's ability for all people to use their own routers. Of course, it's not only a question of freedom of choice, but it's also a question of privacy and data protection, because when we run the software and we control all the parameters in the router, we can, of course, be more or less sure what has, how our equipment is running. And of course, security is a fundamental aspect also running our devices. These are, of course, on the individual level, but also in the social level, on the market level. When we talk about router freedom, we have the question of competition and also compatibility, right? Because if ISPs, they impose just some few models, just some few routers on end users, on consumers, well, we have a problem with competition, right? Because European manufacturers, perhaps they are in a worse position with other types of manufacturers. So there is an individual level and also a social level when we talk about that. And of course, we have been engaged with decision makers all over Europe to bring to their attention that router freedom is extremely important not only for consumers but also for manufacturers. We have been successful already, and I'm very pleased and honored to say that several countries already implemented router freedom as a principle, as telecommunications law. For an example, Germany, Italy, well done, the Netherlands, and Finland. So I'm very happy to know that those countries, they already understood how this is important, and they established this principle in the legislation. In this QR code, if you want, you can access to this map that we prepared. It is a monitoring map, and it tells you all the information in each country. So for those that also are hearing us on the stream, on the internet, you are most welcome to check our monitoring map and check what is the situation in your country. However, there is also some issues that we need to clarify. Even though there are some countries implementing it, other countries not implementing it, we want to understand what are these technological necessities. What are these ISPs, the internet service providers, they are choosing as technological necessities? Sometimes it's hard for us to read contracts on native languages, and that's why you can help us, right? So here there is a link to our survey. There is an end user survey that we are running for all Europe, and there you can tell us what are your problems with router freedom. If your ISP is telling, oh, you cannot use because of compatibility, you cannot use because, well, I don't know, I'm in bad mood and I don't want to allow you to use your router. So tell us, take part in our survey, and you help us a lot. Okay, so this presentation is short, but I really would like you to join our fight, join our advocacy for router freedom. And thank you very much, and I hope to hear your questions.
Thank you, Lucas, for your presentation. Nice to see that Italy is green on this router freedom map. So you're invited to participate at the survey, and other questions. Please come the mic.
Hi, I'm Gianluca Boiano. I want to ask, in the past I was involved to hack some router, ARM-based or something else, and I just seen that the main issue was the ADSL part on many of consumer router, especially the broadband one. So what about these concerns? What about the efforts that are done in this specific ADSL reverse engineering? I suppose if we can hope in this. Thanks.
Oh, yeah, thanks a lot for the question. Yes, from my perspective, from the policy perspective that we have been working, usually the ISPs, when we are dealing with DSL, they are, sometimes we can find issues, but that's not the main concern, at least in several countries in Europe. The problem I just wanted to highlight, we are seeing the future that providers of fiber, they have been quite conservative and quite restrictive right now. So even though some ISPs have some more permissive policies about ADSL and DSL, they are very more restrictive with fiber. So yeah, this is an issue that we have been facing.
So the time is almost over. I would like to thank again Lucas Lesotho for his
And thank you.
contribution. And in the break, there is still possibility to contact him. See you in a few minutes for the next talk. Welcome back in our IoT and cybersecurity session. I'm happy to announce our next speaker, which is Marco Falsetti. Marco Falsetti is Senior Security Consultant and co-founder of the company Enforcer, and he will speak about cybersecurity management in the supply chain. So, looking forward to hear your presentation.
Thank you, and hello everybody. I'm really happy to talk to you about the cybersecurity management in the supply chain today. I already missed the opportunity to be there in presence with you, eventually to further discuss about this topic. But we have just a bunch of minutes, so I won't go into detail about myself, about what I do for a living, what's my job like. I just dive straight to the point. When we talk about cybersecurity in the supply chain, we should try to ask ourselves, what is the supply chain today? Because in the past 20 years, the horizon has changed quite a bit, because the supply chain is no more just a theory, a line of goods, raw materials, or machinery, and whatever we need to just go on with our daily business processes. The supply chain today is something that's just more light, okay? Is usually something we cannot even touch, because it just comprises of all the processes, all the communication flows, applications, software, trust processes between us and our suppliers eventually. So the cybersecurity management has changed quite a bit too, because we are not talking just about raw things, okay? We're just talking about communication flows in the large majority of cases. So we should really ask how we can still trust our suppliers, how we can manage our networks and our processes and our applications when we're talking about and with our suppliers, so we can just have the same level of security posture in a perimeter that's larger than ever, and it's not so easily defined as before. If we have a look at the attack metrics from MIT RE, we see some sort of cases, some sort of scenarios that usually comprises the cybersecurity management in the supply chain. What could go wrong in the supply chain from the point of view of cybersecurity? In the attack metrics, you can just see in the slide some of the problems arising daily. But this is just a little bit of what could go wrong when managing the cybersecurity for the supply chain, because it's just not only development environments or source codes or software updates and distributions from our suppliers to ourselves or from us to our clients. It's not only software, it's not only about development, because this is just would be like the past, the older supply chain, just goods, just things. And it's not really about that. It's just about trust. It's just about who can touch, see, modify what outside of our business perimeter. It already happened, and the supply chain issues made large gaping holes in the cybersecurity of very large companies, okay? About 10, 11 years ago, it happened to Lockheed Martin, which is one of the largest firms in the world regarding aerospace technology, with contracts in the military world. So we're talking about a real giant here. And they had a problem. They saw their cybersecurity penetrated, and it wasn't entirely their fault, because there was just a little problem in the security of one of their suppliers. What happened in the Lockheed Martin security incident, we cannot really go into details here, just because we don't have much time for this presentation. Just have a look about it. Just search in your favorite search engine about Lockheed Martin, RSA, secure ID tokens, source code theft, and what really happened. It was a problem of a supply chain which was mismanaged from a cybersecurity point of view. There was another very large company in the United States, let's just say a supermarket giant in the industry. It's called Target. And Target just had all their systems compromised because of a problem in one of their suppliers. It wasn't a fault of Target, but there was one supplier of theirs, that just got straight into the inner systems because they had the right to do so. The supplier had a problem. Target then had a problem too. And let's not forget what happened in the last 2 years with the SolarWinds hack. You can search for it too. The SolarWinds hack just compromised the security of giants such as Microsoft. Okay, so we're not talking about the supply chain for smaller companies or for individuals. The supply chain could make things go wrong for everybody, regardless of the security posture, regardless of the security budget they can spend yearly to assess, to mitigate, and to patch things up, okay? That's why this is important. There are many theories about how to manage the cybersecurity of the supply chain, and you can see here what they will always tell you, what is written about everywhere in newspapers, in white papers, in magazines, commentaries, larger analytics group. They always tell you that to try to assess your security posture and then to present your suppliers with the chance of presenting theirs to you. So you can really assure that their security posture is up to date, they are doing the right thing, they are following the same standards as you, they are just compliant as you. Sadly, this is far easier said than done, because if we're just looking to see how our suppliers manage the cybersecurity, we could come to a dead end, because it's not really easy to just ask our suppliers if they have done all their homework. Okay, just imagine all the countless suppliers that you can have in your business, from the, I don't know, from everything you've got in your business location, everything you use in your IT department, in your OT department, everything you buy and use to just go on with your daily business. Now just imagine to ask all of your suppliers if they do penetration tests, if they're just compliant with ISO 27000. It's almost impossible. One, because you cannot be assured they are really doing what they are telling you. And second, because it simply does not matter. We just understood in the years that's not the road you want to follow, you want to go through when you just want to assess their security posture, because no matter what, their security posture could change and yours could depend on theirs. So you just don't go asking them for everything so you can make decisions. You will have to make decisions before asking them, regardless of what is the answer to your questions. I know it sounds harsh, but let's go further. One other thing that we are always told about managing the supply chain is to constantly monitor access to information, access to application, access to data. What do our suppliers look? What can they see of our data? What can they use of our applications? What is the exchange of information between us and them? What are the trust flows and the trust settings and scenarios for our communication flow to just go on? Monitoring access is paradigmatic, okay? It's of the utmost importance, but it's just a thing we already do regarding our security posture. We cannot be sure they are monitoring their side of the wall. Okay, let's just imagine a wall between you and them. You can do whatever you want to your side of the wall. You simply cannot be sure what they're doing on the other side. Of course, we have to train our team. If we train our team for upskilling the security posture of our company, of ourselves, that's a good point to ask your suppliers if they do the same, and if they don't, then just try to begin and train their teams too. But is it really important for our cybersecurity? Probably not, because it's not what they do, it's not how they do, it's what we do when we think about our suppliers as just external parties. It was said almost 10 years ago from the FBI director at the time that there are just two kind of companies when we look at them from the security point of view. Those that have been already hacked and those that will be, even if they know that or not. If you just start from this aphorism, we can begin to understand what we're going to do, just trying to manage the security of the supply chain. In the past 20 years, we've just been moving from the older paradigm of preventing attacks and incidents, because it's not really possible. Between 20 and 30 years ago, when the first commercial firewalls just hit the market, we knew we had to defend the outer limits of the company, the border, the perimeter. We just talked about demilitarized zones. We talked about packet filters. We talked about ACL, and that's great. We talk about all this stuff today too. But is it really important when we talk about the supply chain? Probably not, because the new paradigm we've been using since 2 or 3 years is and it's known as zero security, no security. Zero security is just nicer. The point is, do not trust anybody in your organization, so you cannot trust anybody in the supply chain, because they are just outside of your control. The most important thing when trying to managing the cybersecurity of the supply chain is just try to, not to prevent, but to respond, to answer firmly when the time comes. You just have to know what's happening in your network, in your systems, in your application, so you can just try to respond and start again. It's the business continuity is probably more important than the no incident whatsoever paradigm of 20 years ago, because it's not possible. You will be hacked. I will be. Everybody will be sooner or later, because it's just a matter of money, of effort, of timings. It's just a matter of, not of technology, but of our posture on the problems, on the issues of cybersecurity. And sooner or later, we will be hacked. So if we will, what about our suppliers? Of course they will, and probably they already have. And that's the first interesting point about zero security. If we look at principles like the least privilege that's been known in the military world, even in the IT world since decades, in the military since centuries, there is another one or two, like the least routing. We just have to understand what we have to do, what rights we have to do those things, when can we do those things, and how to manage all of this together. So it's not important to defend till the end, because there will be no end. There's no chance of defending any minute of your days. It's just a point of trying to really segmenting, not what we used to do for decades, and just try to see what's happening so we can start again. Let's imagine the classical risk assessment. You will probably have a supplier portal, or even if you don't have a portal, you will have a web application for suppliers. So we will have some technology which you use to exchange information with your suppliers. Now let's imagine a dashboard, a console of this application. In the usual risk assessment, we just go about, okay, it's reachable just by their IPs, IP addresses. So we just put
please come to the end. We already heard the gong.
Oh, okay. I'm sorry. I'm sorry. Okay. Just look at this aphorism. Just remember, I will read it for you because that's the point. If we're talking about technology to solve your security problems, you probably won't be. It's just a state of mind and not a state of technology. And just the second paragraph in the slide, we have done all the things from the technological point of view. In the OT world, in the industry world, they always did what's important for us today. So let's just try to separate from the point of view of privileges, not from the point of view of applications and operating systems. It's just a shift of view, shift of mindset that's really required to manage and assess the cybersecurity of your supply chain. Sorry for being late.
No problem. Thank you for the summary and for your presentation about cybersecurity. So we have no time for questions, unfortunately, and we will come back in a few minutes. Welcome back, dear audience. We continue with our IoT and cybersecurity session of the Free Software Conference. Our next speaker is Luigi Gubello. He's security engineer in the company Small PDF, and he will speak about security metrics for open source project. To you, the stage.
Thank you. Hi, everyone. I am Luigi. I am a security engineer at Small PDF at the moment. Previously, I worked for Arduino, And in my free time, I try to contribute to security in the open source ecosystem, joining the Open Source Security Foundation, and try to contribute to projects related to security in the open source ecosystem. This talk is about supply chain in the open source. So what is a supply chain attack? A supply chain attack is a combination of at least two attacks, one against the supplier and one against the final target or the customer. That can be also another supplier sometimes. And according to an ENISA report, in the last year, we have identified at least 20 supply chain attacks. Some of them are really famous, so probably you have read about them on newspaper or social network. For example, there was a SolarWind supply chain attack, and companies are still investigating this supply chain attack because, oh sorry, thank you. And the attack has been attributed to a APT group, so an advanced group of hackers, usually a state-backed hackers. And other important attacks related to supply chain are Mimecast, Codecov, or Kinesia. How a supply chain attack can affect or impact open source ecosystem or open source project? Well, usually there are three different approaches to try to affect open source project. Why actors want to try to inject malicious code in an open source project? It is quite easy because a lot of companies use a lot of open source code in their backend, in their code base. So usually developers just decide to use a third-party packages that is open source, it is free, there is a good documentation, but they don't have time to check every line of code. They just want to solve a problem, they find the third-party packages that solve the problem, and they want to use it. Usually there are three approaches to hack open source project using to perform a supply chain attack. One is the dependencies confusion. So companies usually use open source packages, third-party packages that are open source, and they use internal packages. So this means that they have written a code, they have created new packages that is not public, and they use for internal repository, for example, private repo. And these attacks work in this way. In some way, the hackers find the package's name of the internal packages of a particular company. Then they decide to deploy a package with the same name in some packages ecosystem like NPM, PyPy, and similar. And in this way, when the developer try to update the packages in their private repo, the tool that they use, so usually are command line tool to update all the packages, or there are workflow, for example, Jenkins workflow, GitHub Action, and similar. The software cannot understand if they need to use an internal packages with the same name, or maybe the packages that is on the packages system. And in this way, sometimes the tool downloads the packages from the external source, but it is a malicious packages. Then there are type squatting attacks. They are very common. So the attacker just create a malicious packages that have a name very similar, maybe with just one or two letters different. And in this way, they want to hack the developer. I mean, the developer don't pay enough attention to choose the right packages. They think that they've chosen the right one, but maybe they are just using a malicious one. And then there are classic hackers. So actors try to hack developer account. For example, if the developer don't use the two-factor authentication, or they try to merge a malicious pull request. So they hide the code in a pull request and they pass the code review in some way. In this way, they can inject malicious code in an open source project, and this project is used by a lot of companies maybe, and this way they can hack other targets. How we can reduce the risk related to supply chain attack? Well, it's not easy. There is no solution. There is just a mitigation and best practice that we can follow. Open Source Security Foundation is a project that wants to create a community to improve and share best practice to improve the security in the open source ecosystem. The main goal at the moment is to mitigate risk related to supply chain attack by doing code review or just tracking the best practice in the project. In particular, there are two tools or projects that help developer, maintainers, but also user to define the security metrics about open source project. One is the OpenSF security metrics, one is the Scorecard. What is the security metrics? The OpenSF security metrics is a website that offers an overview of an open source project by helping people, both maintainers, but also users that want to implement the project in their infrastructure, at home, where you want. And these metrics collect different data from different sources. In particular, there are the security scorecard. It is an open source project. We see in the next slide. Then there are, for example, API by GitHub, GitLab, and other sources where usually the open source projects are hosted. And then there are other information that they can collect directly from the repo. This is how the dashboard appears. It is based on Grafana, and there are information related to the dependencies, the release in the last year, the number of contributors, if the two-factor authentication is required for maintainers. For example, it is very important to reduce risk related to code injection. And there are fuzzing information, so if a particular project uses a fuzzing tool to find vulnerabilities, so it can help you to have a good overview of a lot of projects. And then there is the Open Security Scorecard that is part of the security metrics, but you can run by this tool without using the security metrics also. So you can implement a workflow to use this tool in an automatic way. And so you can have a good monitor of all your open source project that you use for a particular, for another project, because usually you want to use open source project also to create new open source project. And the scorecard can check different security measures that a particular project have. For example, if the maintainers fat their code, if the maintainer have a security policy, or if the maintainer have a CI, for example, and other best practice. So the security scorecard help the maintainers to implement best practice because they receive a score for their project and they can work to improve the security. And at the same time, the security scorecard can help people, user, to monitor the security of a project in an automatic way because they can implement the workflow in the CI and they can automate and improve the overview of the security. And I think that it is all. Thank you. I think we have 5 minutes for the question if you have a question, and thank you.
Perfect. So enough time for questions. Go ahead.
Okay, good. No question.
Seems to be very clear presentation. So a first question from my side. So you mentioned these three typical risks, so namespace, typo squatting, malicious code, injection. Are there a kind of risk maps of typical victims, and depending on the types of organizations or also geographical, maybe geography, where these different risks are popping up and must be addressed differently?
No. Usually, these techniques are just three techniques to try to hack usually a final target that uses a particular open source project, but maybe they can decide to target a small project that is maybe enough popular or it is used in another big project. So in this way, they are sure that the security of a small project is not enough strong, because maybe there is just a few maintainers, they have no time to implement a good security practice, because a lot of open source is written by people in free time without no budget, no funding, so also security is a cost. And the main risk is usually that small projects have been hacked in some way, and but they are used maybe in other important projects, like in the list of third-party packages of a particular open source project. So the maintainers of the big open source project cannot identify easily that a package has been hacked. And at the same time, the maintainers of small open source projects have no time to improve easily the security. This is the focus of OpenSSF, help small maintainers to improve the security and best practice. And at the same time, usually there is no particular risk related to geographical position or similar, because attackers want just to hack popular open source projects that are usually in the production of different companies. And open source is not usually well geolocated, because maintainers can be from every country, so there is no a way to say, yeah, this attack is more common here or here.
So I once heard that cybersecurity is a kind of a visit of the dentist. So
yeah.
Sooner or later you have to do it, and it's
yes.
Maybe painful. So you propose these metrics. So how big is the community of already using these metrics in Italy, for example, and what should we do to enlarge it?
The project is 1 year old, so the dashboard has been implemented in the last year. There is this community that work on this project from 1 year, so it is quite young, in my opinion, the project, but cybersecurity in the open source is quite young, probably also. And in the project, there are probably involved, I mean, I'm considering the Slack channel, 400 people that try to contribute in their free time, usually. And but for example, the scorecard, but also the metrics are on GitHub, are open source, and everyone can contribute to them. And so everyone is welcome. And we are still working to improve it, because there are two difficulties, in my opinion. One is convince maintainer to follow best practice, because it's not easy, especially if you work in the open source in your free time. So you want just to write code, and the security can be a friction sometimes. And then you need to convince also people that use open source to check the security of a particular project, because usually developers want to solve a problem quickly, so they find a good packages and decide to use it without double checking if that particular packages is good or not. And sometimes they have no time to check, really. So having a dashboard that gives you all the information that you need in an easy way, with the green, yellow, and red card, with numbers that you can easily read, and a project that gives you a sort of automated workflow to have an overview of all your open source projects. So the security that have you implemented in your open source project, I think that it can help everyone to improve the security in the open source. I mean, just some little improvement, like the two-factor authentication for the maintainers, for example, can improve a lot the security overall about the open source ecosystem.
I fully agree. Thank you for your great contribution.
Thank you.
And I'm sure in the audience, and maybe also in our virtual listeners, there are some interested persons for some best practices. So thank you. See you in a few minutes. Welcome back at SFSConf at the session IoT and Cybersecurity. Our next speaker is Alessandro Farina. He's IT expert and senior project manager at DSA, and he will talk about open source digital forensic lab 102 Go Mobile. Alessandro, can you hear us?
Yeah, I hear you perfect.
Perfect. So, to you, the stage.
Hi, everyone. Okay. So, welcome to everyone. I'm Alessandro Farina. I have more than 10 years of experience in digital forensics. Our time is very short, so I won't go on with my profile. You can find all the information on the conference website and on LinkedIn. If you got any question after the talk, you can write me down at forensics@thesa.it. This talk is part of a series of talks I'm making with SFConf to raise awareness on how digital forensics is made and why it is important to use free software to avoid in forensics the so-called black box operation. In this session, we're going to talk about forensic extraction of WhatsApp data with the APK downgrade method. First of all, as always, some definition, because digital forensics and digital evidence, managing digital evidence is not just about informatics or information. you have to consider a lot of aspects law related. In short, you should be able to get data from digital device in a way that no one can say you have created or tampered or modified in any way the evidence. You must be able to say who is the author, the owner of the evidence. You must also be able to demonstrate that the evidence hasn't been changed in any way with the extraction procedures. And in every moment in time from the extraction on, you must be able to show that the evidence hasn't changed. In this session, we will use in the lab ADB, the Android Debug Bridge, known also as ADB. ADB is a powerful tool that the developers and forensics use to debug software on Android-based device for maintenance. As requested from the conference, the source code of ADB is full free, so you can access the code, make inspection, and check what the software does in every moment. That's the very important question for me to avoid the black box digital forensics operation. You have to be able to say what the software you are using for digital forensics operation does in every single step. Now we arrive to the APK downgrade method. For a lot of Android apps, the most recent version that are available, when you make the backup, are excluding almost all their data from the file you can raise. For example, on the test device we used for this laboratory, if we make the Android ADB backup standard, we obtain a file of 1 kilobyte, so containing practically nothing, completely useless. With the APK downgrade method, we are able to obtain a file that is much more bigger. What is the APK downgrade method? Basically, someone has discovered that it is possible to uninstall the more recent version of the app and keeping the data on the device, and install a legacy app that allows to backup all the data and the database, files, media of the application, in this case, WhatsApp. So let's go to some of the commands we'll use in this lab. ADB is basically a sort of shell that you use to dialogue to send the commands to the Android device. One command, the first command, the devices list, make a list of all the Android devices connected to the PC. The shell is a run shell command, so directly on the device. It is a Linux flower, basically. Pull makes copy from the device. Reboots the device. Install is used to install an APK, Android packet application from the device. Backup is the command we'll use to make backups from the device locally. Now we are going to see some videos of the laboratory. Okay, first of all, we go in the directory when every file is, the ADB files are installed. ADB devices checks that if any device is attached to the laptop. First of all, starts the daemon. Okay, we found that there is one device installed, my phone, fantastic, it's working. Then we ask for the path where WhatsApp is installed on the device. PM stands PM stands for Package Manager. Then we check if there are directories on the WhatsApp application. In this step, we are downloading locally the APK of the WhatsApp that we will use in a later step. As a result, we have in our directory an APK named original WhatsApp. This is the actually installed application. After making the backup of the original app, we are going to uninstall the WhatsApp from the device. You will notice the key option. The key option means keeping all the data on the device. Now, the step, one of the most important step, we have to reboot the device and wait some moment. Okay. Again, we check that the device is correctly connected. Then we are installing the legacy WhatsApp, the one that allows us to make the backup. Once the installation is finished, we can make the backup, telling ADB to make a backup on a file named WhatsApp.ab. AB stands for Android backup. Okay. Finally, we have 135 megabytes files on the laptop. The Android backup is not directly accessible. We have to make a step, transaction with the ABA, Android Backup Extractor, that gives us a tar file of 307 megabytes. We are decompressed the tar file. You can see the structure of the directories, apps, then com WhatsApp, the part of the app. DB is the part we are looking for that contains all the database of the app. There are a lot of databases. The one that we are interested in is the message store database. In the message store database, there are all the files. Okay. Before analyzing the database, we have to restall put everything back in place, reinstalling the original app that we made a backup in the first step, if you remember. This is to keep the device as it was initially. Okay, the install was successful, so now we can go on analyzing the database. The database we have extracted is a SQLite one, so we can browse with a lot of tools, a lot of free software or tools. We are going to use SQLite DB browser. Okay. You can see here all the tables that are included in the one of the databases that WhatsApp uses. You see a lot of tables, indexes, views. Most of the name of the tables are self-explicative, so you can understand reading the name what is inside the table. Okay, for example, this is the message view. It's a view that keeping together a lot of information about messages and chat. Call log is the table where is stored the log of all the call made via WhatsApp. It could be interesting from a forensic point of view because you can know who is talking who and when. Okay. Now we have seen everything about the APK downgrade. It's very easy. The video was speed up was faster because it lasts some more times the experience. but we basically had a way to explain you how to make the APK downgrade. First, you have to get the legacy APK, and then you can uninstall the application, is keeping the data, reboot the device, install the legacy application. One thing that I want you to think about: once we have the database available, we can change the data and put the modified database back in place on the device. So when you are making investigations on WhatsApp chat, WhatsApp text, and so on, you have to think about this possibility. Okay. We have almost finished, and I'm not sure the result of my talk in English, so at the moment you have some kittens, not to case to leave you with the bad memories. At least if you didn't like my talk, you can always say that you remember me as one of the kittens.
Thank you.
Okay, final information, some links for studying and make some tutorial, some tools that are very important for digital forensics, that are almost everything is free software. For example, Linux, Leo, it's a very good introduction to digital forensic. For me, the basic book you have to read if you're interested in this field. Kane and Tsurugi are two live Linux distributions that you can use to acquire and analyze the digital evidence. The Electronic Evidence Guide is a sum of all the law and the information on the electronic evidence in European Union. Autopsy is a very good tool to make analysis, carving, and so on on forensics images. Here you have another time my email address. I've finished. So if you have any question, I'm available.
Thank you very much, Alessandro Farina, for your interesting presentation and your vivid and live insight in your work. One very short question from the audience. No, so we hear the gong. So we say thank you again to Alessandro Farina.
Thank you to everyone. Bye. See you next year for the next lesson.
And so see you next Free Software Conference, and we take a few minutes again for the connection with the next speaker. Thank you. Hello again, good afternoon in our IoT and cybersecurity session. I would like to welcome our next speaker, who is Vesdin Bezarabov. He's a multiply rewarded researcher from the University College in London, and he will speak about the security of upgradable Ethereum smart contracts and why people keep losing millions. Very curious to hear your presentation. Mrs. Berabov, welcome to you, the floor.
Thank you. Thank you a lot. So let's talk about smart contracts. But first, a small correction. I'm a research student at UCL, and I have some research awards, but we still have a way to get to a really established research level. But nonetheless, I worked in the field of smart contracts for the past 5 years. About almost since Ethereum has been founded, and I find their security very fascinating. So that's what I want to talk about today. There are some very interesting bugs and some very interesting millions have been stolen along the way. So let's go. First, some CV points. Right now, I'm working on research exactly on this topic on upgradable smart contracts. This presentation will focus on defining the problem. So what are the security problems with the current way people do upgradable smart contract? And if you're curious, you can contact me to talk about the research more. And in 2018, I've also developed a security course for smart contracts as well. Cool. So what's a smart contract? So a smart contract is basically a program that has state, variables, and functions. The difference being that it's uploaded on the blockchain, which means it's being replicated on millions of computers at the same time, essentially the entire blockchain, which makes it very secure in the sense that nobody can change the way the execution works. Okay, so essentially the way it's coded, that's exactly how it's going to work, nothing less, nothing more, and it can't be changed by anyone. Very good from a security perspective, but also very bad because essentially people make bugs. And let me give you a couple of very funny stories with smart contracts. So the creators of the virtual machine, so the creators of the actual language for smart contracts, they created a special smart contract in 2016, which was called a DAO. And the idea was for this contract to collect money from all the Ethereum users, and they could vote on how this money would be spent to develop the ecosystem. Very good. This became the largest crowdfunding campaign in history at the time. And it had a bug in it, even though the actual creators of the virtual machine wrote that contract. It had a bug which actually allowed anyone to withdraw all the money collected in this contract, which basically created a huge problem in what was back then the second biggest blockchain, and it probably still is. And another one. So some smart contracts are also used as wallets. So you want to hold money there, but you want to have multiple people vote on how this money should be spent. So like a multi-signature wallet type of thing. And Priority created one of the most widely used wallets back in 2017. But it had a bug. So many people used it to store their money into it. But if you were clever enough, you could actually call the contract's constructor, so its initializer function, and you can reset its owner to you, basically. So every wallet deployed had a bug there, and a hacker stole many wallets. And we saw the development of a white hat group, which had to race with the hacker to hack more wallets so that they could return the real funds to the real owners later. It was a pretty funny story. Then how this developed, same company, same multi-sig wallets, they developed a fix to fix that issue a couple months later. And they really fixed that issue. And but they also upgraded it so that now the contract used the library. What's that is that basically one smart contract which is deployed on the blockchain with common functions and all the other wallets would reuse these common functions instead of redeploying the same bytecode copied everywhere. And that library could be killed. Essentially, it could be removed from the blockchain. It had a function which allowed someone to remove it from the blockchain. And someone removed that library from the blockchain, and every wallet which was deployed was essentially dead in the water. Nobody could actually rescue the funds because the execution of that contract depended on a library which no longer existed, and they are gone forever. So essentially, smart contracts have bugs. And a common way to fix this is to actually make smart contracts upgradable. What's that? Is to have one smart contract, which is the main contract people use to execute, which actually stores the main memory of the contract. And then you have a second contract, which actually stores the instructions. And that second contract can be swapped because the main contract with the data holds a reference to the instructions. This works because the virtual machine here allows one contract to pull the instructions of another contract and execute those within its own memory and function space. It's a pretty clever thing, and this allows the creation of the proxy pattern, which is the most standardized and widespread way that people create upgradable smart contracts. So what's that? You've got one proxy contract which has its own memory, and it has some administrative functions to admin the actual proxy, but it also holds a pointer to the actual implementation contract. Let's call it the proxy contract, which holds the current version of the logic. Okay, the proxy itself holds the actual data, and whenever the user wants to call it the contract, it calls the contract to the proxy, which pulls the instructions from the implementation contract and then executes it internally. And of course, that pointer can be changed quite easily. It's a pretty nice hack around how smart contracts work. And yeah, it's generally useful, but it has many fundamental flaws. Sometimes I could even say it's more flawed than not having an upgradable contract to begin with. Let's talk about them. So first, because the proxy essentially pulls the instructions from the second contract and it executes them as their own, that means there's no separation between the proxy's internal memory and the contract's memory, because the proxy holds the memory of the contract plus some administrative variables, like where is the implementation, like this pointer, or who is the owner of that proxy. So a person who has the right to actually change that pointer, because it must be upgradable. And so you have this lack of separation of responsibilities, where the actual contract code itself can access and modify the internal proxy variables. So if you can have a bug you can have a buggy contract which accidentally, for example, overrides some critical variables in the proxy to render it unusable, or it could be actually a very secret and malicious attack that can be crafted with this. So first problem. Second problem is how you actually call functions. So in Solidity, in order to call a function, you actually have to use the function ID, which is a hash based on the function name. And that hash is actually only 4 bytes. So it's pretty easy to find a collision here. So what happens is someone tries to call, let's say, some function of our implementation contract. So this gets hashed, the ID gets passed to the proxy, and then the VM checks if the ID matches any of the functions already in the proxy. And if it doesn't match them, that means we should actually forward the call and pull the bytecode from the proxy contract and execute it itself. Now, you could actually create a unique function, a completely different function from any function that's inside the proxy, but it could still have the same hash, the same ID as a function inside the proxy. So essentially, you could fool users into thinking that they're actually calling some function of the implementation, where in reality they're calling some internal proxy function that may have different side effects, and it may actually, again, be a pretty cleverly staged attack, even if the actual owner of the proxy is all with good intentions. Okay, third problem is actually fundamental. It's not necessarily to do with the way the proxy is coded, but more around its design. So essentially the proxy pattern is centralized. It means that it requires a single owner to have the right to change the pointer to where the most up-to-date implementation is. So you could easily have a malicious owner who can change the pointer at any time. And because of the way race conditions work on the blockchain, the users never actually know what they're executing before they execute it. So they can send a call thinking they're executing a version of the implementation they actually read and agree, because everything's open source, kind of. And this call in the time this code is executed, the owner could actually change the implementation pointer, and the user can end up executing something completely different. So again, pretty problematic. So our research works to address these issues. I'm not going to get into the details of how we actually do this, but essentially the direction for the solution is, first, you have to absolutely separate the memory and function spaces between the proxy and how it does its administrative things and the actual implementation that you're upgrading. Like, they have to be separate things. You can't have overlap between the memory or between the functions, so that you can have these functions overlap and reachability or other kinds of problems. Second of all, you need better proxy management, because if you have a centralized person who controls the program you're executing, okay, completely, to the extent where you have to trust that person because you never have the guarantee that you actually know what you're executing before it's executed, then sometimes there is not even a point in having a blockchain here, because, well, if you're going to have to trust a single centralized party, then you might as well just have a server and not deal with all the costs and the delays of having a blockchain. So essentially, these decentralized patterns often really don't make much sense, purely in terms of security models. And third, whatever solution we're designing here, it has to be standardized. The crypto ecosystem has its own standards authority, and whatever you're designing, it must be accepted there. With that said, that was a pretty brief talk. I hope that you managed to understand some or maybe most concepts here. We're going to have a few minutes of Q&A, so please feel free to ask anything that might not be clarified, or if you want to dive in anyone deeper. Otherwise, thank you a lot for listening.
Thank you, Mr. Bezarabov.
Thank you.
For your interesting talk about and the insights in the smart contracts and how they can be made surer, more safer and more secure. So are there questions from the audience? So last point, you talked about standardization. So are there already some activities in this direction of the standards?
So the proxy pattern that I demonstrated here, it's an accepted standard. So exactly how you're supposed to code this is standardized, and to many details. There are standards under review right now, which are trying to improve this pattern in different ways, but I couldn't find one that actually addresses these security issues, which seem pretty fundamental. In terms of our research, we're first trying to get a publication out before we are submitting a standard. But everyone can submit one as long as you get enough traction and visibility within the community. The standards authority is called Ethereum Improvement Protocol, so EIP, and there's a website that lists all the accepted standards, and there's a GitHub where you can submit pull requests if you want to propose one.
Any questions? Seems not. So how big is this community, and so are they more driven by the big blockchain communities, or are they more driven by the users, by the companies which they're applying the blockchain in terms of smart contracts?
Right. That's an interesting question. I haven't asked that myself that seriously. So I would presume it's largely driven by crypto users. So people who are largely hyped about crypto and people who have invested or have significant stakes in the crypto world. And I'm not aware of that many big companies having influenced standards before. I think it's just a matter of getting enough users with maybe big enough voices inside bigger blockchain startups or within the crypto community to begin with.
Okay, thank you. Thank you for your presentation, and wish you all the best for your future.
Thank you for listening.
And we will be back in 5 minutes. Hello again, good afternoon in the IoT session, cybersecurity and IoT. Welcome our next speaker, Damashir Hoksha. He's a computer engineer and freelancer, and in his speak he will talk about OpenBGP Web Key Directory, WKD. You have the floor.
Hi. My name is Dashamir Hoja. I will talk about WebKey directory. Now, what is WebKey directory? It is related to public and private keys. In email communication, you can use public and private keys to secure your communication by encrypting it and by signing it. And you need to share your public key with your communication partners. And how do you share your public keys with the communication partners? There are several ways. WebKey directory is one of the ways to publish your public key. And the benefit of publishing your public key with a WebKey directory is that the clients, for example, an email client, can automatically discover it and download and use it, your public key, without the need to ask or to send the public key with an attachment or to download it from a key server. And some other ways to share your public key is, for example, you attach it to an email and your communication partner downloads it and imports it into the keyring. Another way is to upload your key to key servers, and then your communication partners can download it from the key servers. However, both of these methods are kind of deprecated because they have some drawbacks. And the recommended way for sharing your public key is WebKey directory. Now, to understand how WebKey directory works, let's see how a client discovers and finds the public key. For example, let's say that a client wants to send an email to this email address, user@example.org. Now, the mail client will check whether this file, policy, exists in this URL. If it does not exist, then it will check for this file in this URL. If one of these URLs is correct and it finds the policy file, then it means that the WebKey directory works and it can download the key from it. This method is called the advanced method, and this one is called the direct method. After discovering the method which the client should use for getting the public key, then it retrieves the public key from this address. In case of the advanced method, it uses this URL address to retrieve the public key. In case of the direct method, it uses this URL address to retrieve the public key. Now, this is kind of hash, and it is this user, which is the local part of the email address, the hash of this user. And this directory means hashed user ID. So how does the client find out this hash? For the time being, it doesn't matter. It knows how to find it, and we will see later how we can find this hash. But we should know that it just downloads this is a file that contains the public key in binary format. Now, about building a WebKey directory. For the direct method, we need to have access to the web server of the domain example.org. So if the email is user@example.org, we are using the web server of example.org to publish the public key. And for For the advanced method, you need also access to the DNS server of the domain example.org. Let's see first how to publish the key with a direct method, since it is a little bit easier. We create on the web server this directory. This is the document root, and then .well-known OpenPGP key. And then we create the file policy. It is an empty file. It can be an empty file, no problem. Then we export the public key in binary format and save it to a file with this name. Now, this GPG export exports the public key, and this no armor makes sure that the key is not exported in text in ASCII format, but in binary format. Now, we transfer this file to the web server to this location, .well-known OpenPGP key, and then HU, hashed user ID, and the file of the public key. Now, how do we find out the name of this file or the hashed user ID? There are several ways. But we can simply use GPG with the option with WKD hash, or with this option with WKD. And then this is the email address that we want to find out the hash. We are assuming that this key is on the keyring. And we are showing information about this key. And the output will be something like this. Since we are using these options, then it will also display the hashed user ID for this email address, or for this user ID. And so we can copy this one and name the file after this hash. And if we have several several email addresses, or several user IDs, we can export the public keys for all of them in the same way, and then the directory will look something like this. Now, there are some specific things that need to be done on the configuration of the web server. For Apache 2, the configuration should look like this. This option, minus indexes, makes sure that the directory listing is disabled. And the force type application octet stream is needed because this is a binary file. And we also need to set this option that sets the correct headers. After publishing the key to the web key directory, we can test it by downloading it with wget, with something like wget. But let's see first another way to get the hashed user ID. And we can use the program GPG WKS client. We can install it simply with this command. And then we can call GPG WKS client with the option print WKD hash, and then the user ID. And the output will look something like this: the hashed user ID and the user ID. And so we know now what is the hashed user ID. Now, with this hashed user ID, we can construct the URL of the public key that we are trying to download, and we can download it with wget. And after downloading it, we can import it to the keyring. Now, if there is an organization and there are lots of people on it, and we need to publish the keys of all of them, it is tedious to publish them manually one by one. And there are some ways to make this faster and more efficient. And we can use this command to publish all the keys of to publish all the public keys in a certain domain. Now this command gpg with the command list keys lists all the keys in this domain. And then we have this option, show only FPR and box, and the output of this command will be something like this. And now we feed this output to the command gpg wks client install key with the option directory wkd. And in this directory, it will export all the keys. And this directory will look something like this, with all the keys exported. Now, this directory is in our laptop. We need to upload it to the web server. And we can do it with something like rsync or FTP, etc. This is one rsync command that can upload it to the web server, to the correct location. And the advanced method of WKD is very similar to the direct method, only that the URL seems to be like a little bit more complicated or more complex. And everything else that we have said about publishing the keys and downloading and testing them is the same. Just replace this URL with this one. There are some advantages of the advanced method because it is a little bit more flexible because you can host several domains in the same server, in the same WKD server. And it allows us to use a WKD server that is different from the web server. WebKey service. All the methods of publishing the key that we have seen so far are manual. That we run a command, we get the output, we send it to the web server, and so on. But if there is a large organization and the people change the keys often, keeping it up to date manually is tedious and error prone. It is better if each user can update his key by himself. And you can do it, for example, with a web application. There is a form where the user uploads his public key, and then the key is saved in the correct location, in the correct format in the web server. Another way is with WebKey service. WebKey service is a way to publish the public key by email through a specific email protocol. You send a certain message to a certain address, and then it saves the key to the WebKey server. I cannot go into more details about the WebKey service, but if you want to learn more about it, you can look at this blog post. Thank you for your attention.
Thank you very much, Dajamir Hoxha, for your experience of sharing of public keys. There is time for one question. Please come.
What are the main security issue notable issue about security, and is it possible, but I imagine, is it possible to revoke the key?
I don't know about issues about the security, but you can revoke the key because you are publishing it in your own web server, so you can change it whenever you want. You can delete it whenever you want. And it is kind of distributed. If you compare it with key servers are centralized. All the public keys are sent to the same server, which does not belong to you. But in this case, you are publishing your keys to your own server, and you manage it yourself, and you can do whatever you want with it.
Okay, thank you again, and we see in a few minutes for our last talk of today. Thank you. Good afternoon, welcome back to the IoT and Cybersecurity session of the SFS Conf. We welcome our last speaker, last but not least speaker of today. It is Duc Luivu, and he will present us a lightweight approach for securing a Python ecosystem from software supply chain attacks. And he works as the researcher at the University of Trento.
Thank you for your introduction. So this last talk, and I hope to get you something to talk with your friends on the bar or somewhere like that. So this is the work together with Pavel Massaggi, Ivan Paschenko, Henrik Bled, and Antonino Sabetta from SCP Security Research. And I'm Libu, and today we'll be talking about approach that help you to secure the software supply chain attacks. So you may heard about the attacks in the previous presentations, but now I'm going to give you a way to secure the chain. So we are living in the world of open source. We are using open source, and so we might check the source, we might compare it, and we might use it. But in reality, we are using a precompiled packages from a package repository, like PyPI, NPM, something like that. But in reality, what if there are differences between the code in a package in a PyPI packages repository and the code in GitHub, for example? So the question is not what if, but what are the chances? So in our study, we evaluated more than 2,000 packages on PyPI, and we observed that 65% of packages have differences. and 5% of the changes happen in the Python code. What if they are malicious? And so the question now is how to check, how to identify the discrepancies. But what we mean by scale, we have to scale the approach into hundreds of thousands of packages. And given the fact that there are only a handful of developers maintaining, administrating their packages, we have a problem of scaling. Reproducible builds is an approach for making sure that the path from the source to the packet is the same. But it's not scale, because PyPI is a different world. Many developers, many dips, so it's not applied to PyPI packages. Using malware checks, classical approaches, using static analysis, using dynamic analysis, not scale, because even a one false positive must be multiplied by the consequences. Okay, so what the journey looks like? You are a developer. You start developing. You start collaborating with your developer, your colleagues on GitHub, and then you are going to deliver your code, your application. You may use some additional tools to, for example, adding generate documentation automatically using Swagger or CodeChain. Then you have a package, you have a distribution in hand, and you then use a tool called, for example, try to upload your distribution to a packet repository. Okay, but you can see the trend. There are multiple points that the attackers could inject the code, malicious code into a trend. And you are the one who consumes the package. But you are also supposed to read the source, but in reality, not many of us read the source code in GitHub, for example. How about the current countermeasures? So we start from a package. In more precise, it's a release of a package. And PyPI, what it does, it uses a set of rules called malware check, but it also, note that, it also scan using the rules on a set of files, for example, the installation setup.py file. And then, if there are anything suspicious, humans should be the one review the alerts. Okay, this approach is fast, but malicious code can be injected into another file. For example, it can be injected into malicious code can be injected into a different Python file and can be imported at runtime. Okay, one could scan the whole artifact, not only setup.py, but the whole artifact, all files, all resources. They can use a tool called Bandit. It is a tool that first abstract the code into ST3 and then using a set of rules to track the code. The problem is you have to scan all the files, and not all files are malicious, and you may have false positive, and also it costs the computing overhead. Okay, the last resort, you check the source. You have to check the source. First, you have to identify the source code repository of a package, and then you might use some source code scanners, but still, you have to review the alerts. You have to examine the code manually. Our approach. So let me give you a key idea. You're developing something in GitHub, and your users use the package in PyPI, but everything in between is suspicious. If there's any discrepancies in between, you should just examine the discrepancies, not all the package. So this is why we developed last PyMount. First, we identify source code repository. Then we iterate all the commits in the source code repository and collect every line of the files. And then from the package repository, we get an artifact. And then we do the same thing. We hash all the files in the artifact, collect all the lines of the artifact. And then here we make a comparison. We identify the lines and the files that exist in the artifact, but not in the source code repository. You see the key point. And then we call them the phantom files, phantom lines, in which we mean they are the files that are not in the source code repository, but in the artifact, and also for the lines. So we could use the phantom files and lines to filter out the alerts that are associated with them. Also, we can filter out the reports generated by the tools. Okay, let's see how LastPyMal performs on real examples. So you may have you heard about the type squatting attacks. So this is legitimate packages, and this is these are the type of squatting attacks. You may see some difference. For example, instead of requests, you see the request. This is the attack, it's real attack. Or for example, you are with 3, there's lack of error. This is the attack. And about the problem, the coverage, except for the requests on the second line, for the request for the second row from the bottom, all the examples have more than 10,000 of lines of code. This is a problem. If just one line of code goes a false positive, you have problems. Okay, using the default malware checks, you see false positive, right? There's some false positive here. You should not have these false alerts. By scanning the whole package, the situation is even worse. You have many alerts. But using LastPyMal, you can see a difference, right? You can see here. By scanning only the discrepancies, we do not suffer the problem of false positive. Still, we can catch malicious code. Then you see when we combine the LastPyMal with Bandit. Bandit, let me remind you, Bandit is a tool that provides you more precise analysis because based on the AST analysis. And also, by using LastPyMal only, by using the Bandit only, you observe, you got many false alerts. But using the LastPyMal combined with Bandit, you observe zero alerts on the benign packages. But you still catch the actual payload, malicious payload. Okay, it's time to conclude my talk. So in this talk, I'll present you LastPyMal, a tool to help you identify discrepancies between packages and source code repositories. And combined with the other package scanners, LastPyMal is promising to be used for scanning malicious code. So in our future, we are working toward to integrate our LastPyMal with a PyPI, an infrastructure using by the PyPI to check the package. So if you have any ideas, suggestions, feel free to contact us, and you can check our replication package as you know, and the slides here in this. Lastly, thank you for your attention.
Thank you, Mr. Li Wu, for your presentation, and yeah, it is a smart methodology how to identify code injection and to track source code. So we have 2.5 minutes left for you to ask some questions.
Yeah, is there some plan to integrate this with software bill of materials or something that is related to, for example, I want to build not a Python only, but also other project that relies on modules, get fetched from the internet. So there is some technology, a sort of technology that could do to you a hierarchy of dependencies called software boom of materials. Is it something that could be related also at build stage of a project? I don't know if it's clear.
Yes, clear, but I haven't heard about the bomb thing.
So no plans.
Yes, maybe it's a good direction to go. Yes, thank you for your question.
And the last question from my side, you said that a company is actually testing this methodology. Can you say, so which companies from which sectors are most interested in to use this methodology?
I think the company that is just potential customer of our product is a software development company. As every company is like your Amazon, Google, they are now using open source, and they are also maintaining the internal repositories. You see the case of confusion, dependency confusion. This approach could be applied to using for internal repositories. Like every company that are using open source or developing their own repositories, repository. I could say.
Okay, thank you.
Yes,
wish you all the best for the future development. And with this, we reach the end of this session. At the end, I would like to thank all the speakers, namely represented by you. In this moment, I would say a big thanks to our technical staff, which were very professional. And at the end, also all participants. And we're happy to see you next year at the next SFSCon. Thank you.